In today's class of complex analysis, I am going to teach you all about the isolated singularity at infinity. Okay, so let me start with it. First, I will start with the definition. So, isolated singularity at infinity. Let f of z be a complex valued function, then singularity of f of z at z is equal to infinity is same as singularity of f of 1 upon z at z is equal to 0. Okay, so this definition is very important for you all to remember. Okay, so I will be solving an example based on this. Okay, so let me start with it. So here what is given with you all? So here what you all have to do is find singularity of f of z at infinity, then we have to find singularity of f of 1 upon z at 0. Okay, so what you'll have to do is, let me do it with this. First what you'll have to do it, what is given, f of z is equal to z, right? That is z is equal to infinity, right? So f of 1 upon z, so replace z by 1 upon z. Okay, so that will be at z is equal to 0. So we know that z is equal to 0 is a pole. Okay, so what? So limit, so what I have done is, over here I have taken the limit z tending to 0 f of 1 upon z. So in place of z I have plugged 1 upon z is equal to limit of z tending to infinity, 1 upon z is equal to infinity. Okay, z tends to 0, 1 upon z is equal to infinity it is. So next what I'll have to do is, z is equal to 0 is a pole, right, of f of 1 upon z, and z is equal to infinity is also a pole of f of z. So let us see the next example, that is the example 2. Let me zoom it for you all. Okay, so find the singularity of f of z is equal to e raised to power of z at infinity, f of 1 upon z is equal to e raised to power of 1 upon z. So what you will have to do is, in place of z, replace this z by 1 by z. Okay, in place of z, what you will have to do, 1 upon z. Can you see in the definition over here? I am using the definition to solve these problems. Okay, examples, to solve these examples. So e raised to power of, wherever z is there, plug 1 upon z. Okay, so take the limit where z tending to 0, e raised to power of 1 upon z does not exist. So this does not exist. So what will happen? So this will automatically implies that z is equal to 0 is essential singularity of f of 1 upon z is equal to e raised to power of 1 upon z. Okay, and also it implies that z is equal to infinity. Here z is equal to 0 is essential singularity of f of 1 upon z is equal to e raised to power of 1 upon z, right? And z is equal to infinity is essential singularity of f of z is equal to e raised to power of 1 upon z. Okay, next let us see. Now here is the question, if they ask you all about this singularity f of z is equal to z cube plus z at z is equal to infinity. So you all have to see whether this is removable singularity, pole, essential singularity, or none of this. Okay, so which option is correct? For that you all need to solve this. Okay, now how we are going to solve this? So f of 1 upon z in place of what? So what I am doing over here is, in place of z I will be plugging 1 upon z, okay? So let me do this. 1 upon z is equal to 1 upon z cube plus 1 upon z, okay? So you all have to see over here, okay? 1 upon z, 1 upon z cube. So that's what I have done. So now here it is equal to what? 1 plus, take the LCM, z square upon what I am going to get? This is z cube, right? So now what I am going to get is 0, 0, 3 times 0, right? So basically z is equal to 0 is a pole of order, is a pole of order 3 for f of 1 upon z, right? Same way, z is equal to infinity is a pole of order 3 for, okay, that is for f of z, okay? So you all have to know this. See, z is equal to 0 is a pole of order 3 for f of 1 upon z, and z is equal to infinity is a pole of order 3 for z is equal to f of z, and this is f of 1 upon z, right? So option B is the correct one, okay? So option B, this one, okay? So next let us see the other one. Basically this is the question number 2, okay? So singularity of f of z is equal to z 1 upon, what is the z, 1 plus z at z is equal to infinity. So you all have to see whether it is removable singularity, pole, essential singularity, or none of this. So which option is correct, that you all need to check. So for that what you all need to do is, f of z is equal to multiply with this, then multiply with this. So z plus z square you all will get. So let me do it. F of z is equal to z plus z square, okay? So f of 1 upon z is equal to 1 upon z plus 1 upon z square. So this is nothing but z plus 1 upon z square, okay? So this is what, so you all are going to get z is equal to 0, 0, right? There are twice. So z is equal to 0 is a pole of order 2, is a pole of order 2, okay, is a pole of order 2 for f of, okay, let me wrap this part first. This won't fit over here, right? So let me write it again. So basically you all need to know this. Z is equal to 0 is a pole of order 2 for f of 1 upon z, it is 1 upon z, it is. Z is equal to infinity is a pole of order 2 of f of z, okay? 2 it is. So now which option is the correct option? This B. So option B is the correct option, right? So now next let us try to do it. Singularity of f of z is equal to z e raised to power of 1 upon z at z is equal to infinity. Let us see if it is removable singularity, pole, essential singularity, or none of this. Okay, so how to do this? So first, what in place of z, plug 1 upon z is equal to 1 upon z e raised to power of z. Okay, so z is equal to 0. So what we have to do over here is, so basically z is equal to 0 is a simple pole of f of 1 upon z. Okay, and z is equal to infinity is a simple pole of f of z. So the correct option is again the B one. Okay, I hope you all have understood today's lecture, and thanks for watching. In the next lecture I will be giving you all more about complex analysis. Thanks for watching.